don't know why we're forced to see it. It's really not supposed to be done anymore. There's my helicase splitting. Here's my RNA, well, my single-stranded binding protein, stopping it from annealing together as they come apart. There's my RNA primase. It's laying down the green one, which is an RNA primer, right? There's my primer. That gives me the 3' end to it. My DNA polymerase 3 will latch on. Well, this primer, remember, is way down here somewhere where it started. So there's the DNA polymerase 3, elongates the DNA, adds to the nucleotides. For the Okazaki fragments, when the DNA polymerase 3 comes up against an RNA, it detaches. What will go on that's not in this picture? You can find another picture that has it. Is a DNA polymerase 1 that will remove the primers and add DNA nucleotides, and then I end up with the little piece that's not connected. And I need to put a DNA ligase to put the phosphodiester bond. So there's got most of them. But if you just go to Google, a lot of times you'll just find all these things. This is where I find them all. So let's see if we can find this one with even more on it. Here we go. So just pull up another picture. There's an Okazaki fragment. There's the beta primase. Anyway, someone here somewhere. Oh, where's one? So this one here has the DNA ligase, right? It's putting two Okazaki fragments together, right? There's an Okazaki fragment right there. This one just doesn't show you the primers that are in there. But there's a DNA polymerase building it in one direction. See all the sorts of different sort of pictures, but they contain the same thing. There's the helicase, right? Splitting it. This one just doesn't have the topoisomerase on it. But if you look at some of the pictures, you'll find all of these things which we talked about. And if you go through and you look at the dark ones, you do them step by step, right? Topoisomerase, that's the one that unhooks one and does the rotating. This one does, if one's on one side, you have to cut both and allow the strand through it. So you get all that. Splits it, stops it from annealing, puts down the RNA primer, so DNA polymerase 3 can latch on, add the 3' end. It grows until the end where it comes off. DNA polymerase 3 latches on, takes up the primer, which is right here, adds DNA nucleotides, and then the DNA ligase joins those two pieces together. The DNA polymerase 1 cannot put the end one together with the other one. They do that last phosphodiester. Leading strand, that's the one that is building towards the replication port. That's this one, so it's building towards the port. And the lagging strand, or the Okazaki fragments, are the ones that are building away from the port. So you saw that sort of that video from Bio2 Institute that sort of shows you it's a little more complicated. So. Translation, yep, so that's one. Is it going to be on it? Yep. All part of proteins, right?
So, after protein transcription, that's when translation happens, right?
Yes. Then it moves into the cytoplasm.
The transcription is
this is DNA
to
mRNA. First half of the central dogma, right?
mRNA to
protein is translation. So here just to pull up a picture. Would I find a picture somewhere of this stuff? One that's good one, right? So if you look, first thing, remember, I and AP bases. So the promoter region, of course, which this one doesn't show you, but the promoter region would be upstream. That's where we split it. That's where we start splitting this thing because it has fewer hydrogen bonds than a CG bond. Take loss energy. So that's where our RNA polymerase will join to the promoter. RNA polymerase, of course, you know, there's this is a primase. It builds. This is what builds RNA. So it uses RNA. Again, RNA polymerase will read the DNA in a 3' to 5' direction. It will build the RNA in the 5', 3' direction. So remember, you go to the genetic code. AUG was what? What was AUG? Start codon. Good. So for all intents and purposes, for us, we can say that it starts building. What is that in DNA?